scale your cloud without breaking the bank. A little bit about myself. My name is Natalie Godec. I'm a platform engineer at Babylon Health. We are a digital healthcare company. I do all things DevOps and infrastructure, and I love it. I find it a very creative field, and we get to solve very complex, very interesting problems as a day job. And I also do photography, and you can find me on Instagram and Twitter at W.I.T. And I would like to start by introducing Babylon a little bit for those of you who might not be familiar with, especially that we have people from different countries here. We are, as I said, a digital healthcare company, and our mission is to put an accessible and affordable health service into the hands of every single person on Earth. And by that, we mean it. We develop digital health services and as well as medical AI that can be installed on mobile devices. It can be used on very sophisticated smartphones like we have here in Western Europe, but also we operate in Rwanda, where it is a more simple service that is nonetheless available to the populations that otherwise wouldn't be able to access a doctor that easily. There, it's just in their hands with their mobile device. And we operate on both AWS and GCP, and as well as some on-premises infrastructure. And I've been at Babylon for about a year, so it's been a lot of very interesting experiences learning cloud and operating across 2 different clouds. And I would like to say a few words about the cloud itself, and especially as we are multi-cloud. What is the most known, the most famous incentive for people to go cloud, to deploy their applications and their infrastructure into the cloud, or migrate their existing services into the cloud? Well, it's the very well known, you can build fast, you can scale in seconds, and you only pay for what you use. Something that is very, very interesting for the executives out there: you don't have to provision your infrastructure, your servers, and pay for them thousands of dollars or pounds or euros, depending where you are. You only pay for what you use. Isn't that great? But it also is really interesting for startups, because when you are just starting, you want to develop your application and do a POC, do a beta version, and get it out there and get people to use it and test it and give you feedback so that you can iterate and you can scale up or scale out, improve your application. So build it fast, scale it immediately without having to provision that infrastructure beforehand and only pay for what your application is using is amazing. And people are noticing it. Like this guy on Twitter, he just spun up some infrastructure immediately to triage 12 million images. That's incredible. And he would just do it and paid for $10 for that. That sounds amazing. But is it? They forgot a GPU instance. And you might or might not know, but GPU instances are very powerful. However, they are very expensive as well. And this company has noticed it at $3,000 bill because they forgot to turn the instance off. And this is so much true when you operate in production and you go and scale into different regions, different environments, that it's becoming a known thing. Like the right definition of the cloud is not that you pay for what you use. You pay for what you forgot to turn off. A very true tweet by this guy. And you might think, okay, no, well, this sounds very trivial and I will never do that. I will never forget something running in production. You might be right. I hope you're right. But even the best of us, when you scale out and you have new deployments and you need to serve thousands, tens of thousands, tens of millions users, these things tend to happen, and then you get Jira tickets asking you to turn off 2 large databases and save $5 grand. How did that happen? How did 2 databases that have never been used, how did they get into the environment and get left there without anyone noticing? That's what I want to talk to you about. So I want to explain the methods that you can use when you develop your infrastructure and you deploy things the tips and tricks that we found that you can use to avoid being the guy on Twitter or girl on Twitter saying, oh, we forgot to turn the GPU instance off and it billed us $3,000. So what are those tips and tricks? There's a few of them, and we at Babylon found them very useful, and that's why I wanted to share them with you. First things first, you have to tag everything. And I really mean it, because that allows you to know which resources belong to which team, to which service, to which application. When you want to have a look at why your bill came in so big or so little, you can triage and see very, very well graphically which resources are being used by who. And if some application is suddenly becoming quite greedy, you can go to that team. If you have a tag that says team, name of the team, unicorns, you can go to unicorns and say, hey guys, your application is being a little bit resourceful. Is everything okay? Is that expected? Have you budgeted for that? But to be able to do that, you will have to tag everything. And our team spent 2 or 3 weeks, I think, in March, where we went out and we tagged all of our RDSs, all of our EC2 instances, S3 buckets, everything. And then after you've done that, you have to monitor your resource usage and your resource costs. Why is that important? When you have provisioned something and you estimate that your application will need a large instance, and then you expect it to run that way, and you will be billed for a large instance, which will be quite expensive. However, your application is not actually using that amount of power of CPU, of memory, then you are being billed for nothing. You're not using those resources that you have requested. And unless you monitor your resource usage, you will not know. So you need to utilize the tools that you already have. If you're using AWS or GCP, I'm sure Azure has the same things. I'm not familiar with what tools they have in Azure. But in AWS, you have Cost Explorer, where you can monitor your usage, your costs, your trends, depending on your environments, and service charge types, and your instance types, resource types, etc. In GCP, it's called billing. You can build very powerful, very detailed billing reports that will allow you to know where and how you're spending. And also, if you already have the data, you can pour it into your favorite dashboarding tool, which for us is Grafana, and build dashboards that are really tied into your perspective and your needs. For instance, if you're in a development team, you would want to probably see the trends of the resources that are used by your application or your service that your team is developing and is responsible for. And sometimes maybe for your business, it makes sense to invest in a paid tool, such as Cloudability. This talk is not sponsored by Cloudability, but we do use it and we pay for it, and we found it very useful when figuring out where we could cut costs, where we could optimize our resource usage, etc. And I will show each of these tools later on so that we can see in practice what we can do with them. And then when you have that data, you've tagged everything, you've monitored your usage and your costs, and you have all of the data and you're looking at it, you can make decisions that are driven by the data. You can consider maybe you can change instance types or even use preemptible resource types. Those would be in AWS your spot instances, Aurora DBs instead of RDS instances. In GCP, it's called preemptible compute instances. Those resources where you can run your service without having a guarantee that the instance will always be there. If your resource allows to be stopped and restarted elsewhere without any interruption to it, then maybe you can consider using preemptible resource types, instance types. And if you have, I hope you do, development, staging, and production environments, then maybe your developers don't work on the weekends or at night, or maybe there are other times of day where some of your infrastructure doesn't need to be run. But for all of that, you first need to have a lot of data to base the decisions on. So let's have a look how we can do that. In AWS Cost Explorer, you can have graphs of your cost and spend. There's lots of reports that are predefined by AWS, or otherwise you can create your own. This is a very simple one that shows over the past 6 months, the spend trends on different AWS services. So we have RDS, EC2, taxes, because you have to take that into account as well, EC2 instances, CloudWatch, and other resources. And even on this little small graph, you can see an interesting trend where RDS costs are going down. And that is happening because we've done a lot of work of putting away the RDS instances that we don't use, finding them, tracking them down, shutting down the resources that we no longer need. Maybe the services have been decommissioned, etc. And also right-sizing databases. Maybe someone doesn't need a 2 extra large RDS instance. Maybe they can do with a medium one. And this is really showing in the cost reports, and it's nice to see. If we look at GCP, I've tried to create the same kind of report as AWS. This is the past 6 months, according to the resource type. You will notice that we use different services of AWS and GCP. We use GCP for our data platform. So you can see on the right, BigQuery, KMS, Compute Engine, Composer, logging, and cloud storage. And you can see trends as well, where you can analyze, okay, what happened there? What happened between February and March? Why did the cost go up so much? And maybe there is an insight that you can act on. Maybe you should do something about it, or maybe there isn't. In our case, for instance, the usage is going up because we are popularizing our data platform with the analytics teams, and they're using it more and more. And so logically, the costs are going up, and that's budgeted and planned. And we can check with the teams whether they are doing what they have to do and what they can do to optimize their usage and their expenditure. One interesting thing that GCP has, and I want you to really pay attention to it if you do use GCP, or if you consider using GCP, they have suggestions, advice, recommendations for the things that you use. This exists for cost, but also for access patterns, which is a completely separate topic, but they do suggest things like that as well. You can see 3 Tableau instances here and suggestions that might save $75 a month on each of those instances. All of those are clickable in the console. If you go into the console and you see a little orange light bulb, you can click on that and see what they suggest. It usually means that the instance type that you're using is too big, or maybe it is too small, and then they will suggest to bring it up a bit. And this is very handy where you really have to estimate, like if you're deploying something for the first time, you will likely estimate how much resources is needed, how much infrastructure is needed, but maybe not exactly aligned to the reality of how this service will behave. So then GCP just tells you, hey, you can save some money, and that's very nice. I wouldn't be able to talk about cloud costs without talking about Kubernetes. So in Kubernetes, the way resources are allocated, as you may or may not know, each of the services in Kubernetes can request a certain amount of resources, a certain amount of CPU and a certain amount of memory. And then Kubernetes will go and allocate those CPUs and that amount of memory to that service. And that is a very important thing to monitor. And let's explore how we can monitor it. Because when you allocate that amount of memory, it will be allocated to that pod, and no one else will be able to use those resources. Whereas maybe your service doesn't need as much. So how can you do that? How can you find out whether or not your service needs the amount of memory that it requested? There is a very magical command called kubectl top. So a little alias is created. kubectl top pod, name of the pod, in the namespace you need to have a look at. So let's see what we have. We have an anonymizer service. So let's see which pods it has. Dev and grep for anonymizer. Lots of them, but I'm interested in anonymizer itself. So I'll get the name of the pod. And then I will do kubectl pod name and the namespace. What this gives me is the actual current resource usage of that pod. And of course, that probably doesn't tell us much. So what we can do is automate that. The CLI is there. You can, if you have a list of services that you are deploying in Kubernetes, you can easily automate that. You've seen what I did. I did kubectl get pods based on the name of the service, or the name of the deployment, and then took the name of the pod and did top pod on that. So that's a very easily scriptable thing that we can do in Bash. Show demo script and have a little script for that. So if we have a look, we can have a list of services that we want to analyze. We do a little for loop where we take each service from the list and get all of the pods of that service and write the actual current usage of the resources for that pod into a results file. And then do a little magical compilation of grepping and cutting into a different file to have a better representation. So this is really, really simple, just 2 for loops that do a bit of formatting, a bit of grepping, and 2 kubectl commands. Let's run that and see what happens. Oh yes, let me show you the list of services that I would like to analyze, right? So, 4 of them. We can see the names of the services, and you can, depending on how you deploy your applications, you will compile this list in a different way. We use a tool called ShipCat. It's an open source tool developed by Babylon that manages our Kubernetes EKS deployments, because we use EKS, Amazon's managed service. So I got these names of the services and the numbers from so-called manifests from ShipCat. But whatever tool you use to deploy your Kubernetes and your applications, you can find the requests and the limits there, right? For each service, the number of CPUs and the amount of memory each service requests. And so the numbers here are the memory requests for each of these services. So if I run the script that I just showed you before, it will take a few seconds to run all the commands. And you can put, this is a very simple thing that you can do, and you can put it in a cron job, for instance, and have that data stored somewhere. You can store it in a bucket or in Logstash, pop it up into a database, link it to Grafana, make a dashboard, give it to developers, give it to your team, say, hey guys, we're requesting this, we're using this, let's fix that. And this is just the way we've written this script, and a representation of, we did an analysis of the services that we run in order to give that data to our development teams. So we can see here, first service is concept builder requesting 7,000 using about that. Perfect. This is pretty much on point. You requested that, you're using that. Magnificent. But then knowledge algorithms is using much less than it requested. That's not as ideal. And then anonymizer is requesting 6,000 and using 2. And the BigQuery writer is requesting 5,000 and using, on average, 1. That really could be optimized, right? When you look at this, and if you didn't look at this, you would never know. And you would think, oh yeah, that's fine, and that's how much I'm using. And hence you would need more Kubernetes nodes, more instances, and you would pay more. And this all adds up very quickly. One thing to remember in the case of Kubernetes is that maybe the pods are using this amount of memory right now, but maybe they need more at some other time. And for that, you really need consistent and continuous monitoring of the resource usage. And that's why I'm saying you need to have this data available somewhere, and you need to build dashboards. And by dashboards, like really, you can use any dashboarding tool that you like. We use Grafana. You can visualize your usage metrics. Most people know Grafana and use it to monitor their availability of their services, their performance, network latencies, and so on. But you can also use it to analyze whether your services are requesting the right amount of resources. So if we look at this dashboard, it will take a few seconds to load. For instance, you can map for EKS, for each of your microservices, so your applications. You can map the actual memory and CPU usage to the requests and to the limits, and map that over time and have a really good scale of what's going on in your Kubernetes clusters. So this is how the dashboard looks for us. So last 30 minutes, let's leave that. This is the dev cluster, so I'm not showing anything bad. What were we looking at? We were looking at anonymizer, right? So let's look at anonymizer. And here you can then see that indeed it's using only 30% of the requested memory and pretty much none of the CPU. And it has been consistently like that. And I can load this for over time for the past 2 days. Let's do 2 days and really see the trends. And we've decided to use gauges to show usage compared to limits and requests. But you can also do graphs for that and see if maybe if your ratio of memory usage compared to requests is at 31% all the time, then maybe you can lower down your requests to that amount, and then your usage will be optimized and your cost will go down. But really, you need to continuously monitor that and give that to your developers. Or if you are a developer, have a look at that and see it and act on it and improve your application. And then you can do more if you use more tools. Maybe it makes sense for you to invest in a tool that can help you decide what to do with your infrastructure and sizes. Maybe you have grown so much that you can't possibly do it yourself using little shell scripts. And in that case, it would be useful for your business perhaps to spend money to then save money. It does work like that sometimes. So this is Cloudability. It is a cost management service where you can build different dashboards and reports. And in this particular slide, you can see that this is an estimate of how to right size RDS instances in this particular environment. We can have a look at the dashboards itself. This will continuously monitor for you your RDS use, and continuously monitor for you your RDS spend. And then, for instance, very interesting bit is the idle time, whether or not your RDS instance has had any connections recently, and these ones haven't. So the action that Cloudability recommends is terminate. That would be great to do, right? Or perhaps this one doesn't really need to be an extra large. It can be a large and a different instance type from T3 to M5 that would be optimizing the instance type and size for the amount of use and amount of connections that this particular RDS instance gets. And you can do these kinds of dashboards for all kinds of cloud resources if you connect your cloud accounts to Cloudability. And obviously there are other tools out there as well. This really helps when you have loads of resources. We operate in UK, Rwanda, Southeast Asia, USA and Canada. Each of the locations has at least pre-production and production environments. And we have probably about 300 microservices. So that's a lot of resources to monitor. And sometimes we do need some help with our analysis of the infrastructure. So that's why we use Cloudability. And it also produces nice reports like this over time, depending on where, like what kind of resources you use, where it is. You can choose the metrics, you can choose the lanes of what you show. And I spoke about tagging at the beginning. So you can choose that you will show EC2 instances and by tag environment, and then by tag team. And then it will show you all of your, how much all of your EC2 instances cost in a particular environment for a particular team. And again, that empowers you as maybe a DevOps person or maybe a developer to go and see that, oh, okay, we are spending that much in production and that much in development. Maybe there's some adjustments to do. Or maybe not. Maybe you're perfectly fine and you're spending exactly as much as you estimated. And then you're a very, very good estimator and your infrastructure is good. Once you have the data that you collect, like this is from the GCP billing, and I have to say I really enjoy GCP for the fact that it just gives you all of this data and these dashboards and graphs already on its own. You don't have to do anything. But then you have a look at this graph. Do you see anything in it that might be interesting? Apart from the fact that end of August, for some reason, we had a spike in use, while end of August typically is the vacation time, should be. But we had a spike, very productive. But other than that, there is a repeating pattern here. And that pattern, unsurprisingly, is that on the weekends, the usage is going down. The cost in this case is going down, but because we know the type of resources that we use on GCP, those are BigQuery, GCS, KMS, the things where you pay when you use it, when you actively query data. On the weekends, the cost is going down, and that means that the usage is going down. So maybe it would make sense to actually turn some of the infrastructure off at the weekends. Does it need to be running? Do we need compute instances running on the weekends? Maybe we do, maybe we don't, but that's something to discuss with the teams that are managing those EC2 instances and see maybe we can do something about it. But again, maybe not, and maybe this is just something that we have to live with. But having this insight and having the data in front of your eyes, and by the way, for those of you who are not in the UK, if you might be wondering why the weekend of 29th of August is 3 days, it's because that's a bank holiday. And that's why we see a nice curvy downtime in the costs. This is something that you really need to consider, because think about it. If you have like a production deployment and it's using a Kubernetes cluster of 10 instances, even if they are spot instances, you will still have to be paying for them. And then it's a development cluster. I said production, not production, development. It's having a Kubernetes cluster and all of your services are running there. And then you have maybe 5 database instances that are also running there. And then you have a load balancer, proxy, all of the networking, everything is running, but all of your developers are sensible people and are not working during the weekend. But it's still running and you're still paying for that. Should you be doing that? Maybe should you try to turn it off on the weekend? It would be also a really nice chaos test for you to do. If you turn all of your infrastructure off and then back on, will all of your services come back? That's a good disaster recovery as well. But you have this data in front of you, look at it and analyze and see what you can do. And then just be a happy chap who has saved so much money to the company that can go and do something new and cool and explore new resources and new infrastructures or applications, whatever you're into. And this is the slide to screenshot everything that I've been talking about. Tag everything. Please do that. Please tag everything. Even if you don't think you need it, you do. Please tag everything. Continuously monitor your use and your costs and compare them through applications, through cron jobs, through shell scripts. Empower your teams with that data, with the continuously monitored use and cost. Empower your teams to make changes. Consider making architectural decisions such as using preemptible resource types and instance types. And maybe shut down your environments when they are not used and don't have to be running continuously. Again, screenshot this slide. Do that now. And that's all from me. Thank you.